Hello everyone, welcome to UNC Portal class and today's lecture on topic ARM instruction versus thumb instruction. As you know, in case of ARM procedures, we have to already know that whenever we have to executing any types of data value or any types of commercial application elements, in this case it requires all over the instructions that to be executed through 32-bit instruction format. But as you know very well, in case of procedure, whenever we have to performing any types of interpretation or calculations, every procedure that to be required different types of instruction for performing different types of job application in an accurate ways. Okay. Similarly, in case of ARM procedures, the ARM processor uses different types of instructions. Some of instructions which are given values, that's your one is the ARM instructions and another one is the thumb instructions. In case of ARM instruction, when the ARM processor to be executed any types of data elements, here all over the data that to be executed compulsory its length width, that's your 32-bit. That means whenever we have to executed any types of data value in case of ARM processor through ARM instruction, here every instruction or of course size elements by default that's your 32-bit, whose index number to be starting from 0 to 31 when that to be located in between your memory through the concept of little Indian allocation methods. Okay, but if we have to executed this of course through the help of thumb instruction, here the thumb instructions to be required 16-bit memory location for executing this given opcodes. That means here this given opcode or instructions to be required 16-bit whose range to be starting from 0 to 15 in between memory locations through the help of also Little Indian memory organizations. Okay. Then after that, if we have to execute all over the instruction through the help of ARM instruction, in case of ARM procedure, here the ARM instruction requires 3 address field. That means it requires 2 address field for the given operand and 1 address field for the given outcomes. Okay, 2 address field for the operand and 1 address field for the resultant outcomes. That means the destination location. But if we have to execute this given job through the help of thumb instruction, here the thumb instructions to be supports 2 address instruction mechanisms. 2 address instruction mechanisms. That means here the 2 address used for the given operand and the resultant to be stored any one of the source operand locations. That means here the resultant outcomes to be stored any one operand. For examples, suppose we have to executing one instructions, here the opcode is add, then another one register that's your R0 and another one register that's your R1. That means here the summation of 2 registers data value to be performed through the help of R0 and R1 and their resultant to be stored any one location of this given operand locations. That means here suppose the resultant outcomes to be stored on location R0 equal to R0 plus R1. Okay, but if we have to executing by using the ARM instruction field, here the ARM instructions to be compulsory required 3 address field. That means suppose we have to performing the addition of 2 numbers, here R0, R1 and another one is the R2. That means here the source operand locations to be different from the resultant locations. Here the meaning of this given instructions, that's your R0 equal to R1 plus R2. Okay. That means in case of ARM instructions that to be provides whenever we have to performing any types of interpretation, here more number of binary registers to be required, but in this case less number of registers to be required for the job executions. So another difference, here it required more registers, binary registers, but in this case it required less binary registers. Binary register for the data interpretation. Okay. Then after that the ARM procedure also to be used, the ARM instructions, when we have to executing any data elements through lesser density of the code elements. That means in case of ARM instructions, whenever we have to executing any types of data elements, here more complications to be occurs, so that the density code in this case less density code, but here the code density is very greater as comparison to ARM instructions, because in this case it provides one facilities. If we have to need for compressing all over the ARM instruction code and reduces format, in case of thumb instruction that will be possible, so that here the code density is very greater. Okay, is very greater. And another facilities that to be provides in case of ARM instructions, when we have to performing any types of data calculation in case of ARM instructions, here if we have to needed for assigning one of very important fact of the given elements, in this case the ARM instruction is the support part of the thumb instructions. That means the parent of the thumb instructions, that's your ARM instructions. That means without the help of ARM instruction, the thumb instruction cannot be possible. That means the thumb instruction is the sub part of the given ARM instructions. Okay, that means whenever we have to require for converting all over the 32-bit data elements and compressing format and 16-bit reducing format, in this case we have used the thumb instructions. So that always the thumb instruction is the sub part or child part of the given ARM instruction, sub part of ARM instruction. Okay, then after that another difference that to be provides in case of ARM instruction, when in case of ARM instruction we have to executed any types of data elements, here that to be consumes much more electricity and the performance is very less. That means the throughput of the given processor is very less as compared to thumb instruction. That means here less throughput, and another one is the low performance, and also that to be consume very much more electricity. That means the power efficiency here is high. Okay, but as here in case of thumb instructions that to be executed by using very short number of registers, in this case that to be provides all over the data to be executed through very low power efficiency, and also here the performance is very high and the throughput is much more. That means in case of thumb instruction that to be provide high performance for the job execution, and it to be provides the throughput is much more, and another facilities that to be provides it to be consume very less power. Okay, less power. Another question here that to be arises, as you know in case of ARM processor, whenever we have to interpreting any types of data value, all over the data value that to be represented through the format of through the help of assembly level language. That means all over the different hardware that to be easily interface with one to another through the help of assembly code. And the assembly code whenever we have to interpret, in this case the data value cannot be directly insert, so that we have used the register for the data insertion. So now one question arises, how many registers that to be provided in case of ARM instruction executions, and how many registers that to be provides in case of thumb instruction executions. When we have to execute any types of data value through the help of ARM instruction, here the ARM instruction provides in case of ARM processor, that's your 15 general purpose registers, and another one registers, that's your program counters. Okay, and in case of thumb instruction, when we have to performing all over the data execution and compressing format or sub part of the given ARM instruction, here it to be provides 8 general purpose registers plus 7 high registers, and the last one registers, that's your program counters. That means In case of ARM instruction as well as in case of thumb instruction, whenever we have to perform the data manipulation, here by default provides 16 registers. But in between 16 registers, some registers have general purpose and some registers have special purpose. And through the general purpose registers, it provides 7 registers for the user data process manipulation purpose and other some registers for the system code manipulation purpose. Okay. Then now goes to our next difference. In case of ARM instruction, as we know, it to be provides 16 registers for the data interpretation. In case of thumb instruction, it also provides the 16 register for the data interpretation. But one difference in between this instruction, if any types of exception here to be occurs, in case of ARM instruction, it provides one register that shows CPSR, that means current program status registers. This CPSR to be directly mapping with the ARM instruction code for execution all over the data elements in accuracy way. If any error to be occurs, that to be handling through the help of SPSR, means Save Program Status Registers. So that as here the ARM instructions to be directly mapping with the given exception code. So in this case, it to be provides one flag bit that's your flag status bit that's your T equal to 0. That means here the triggering status bit that to be 0. But in case of thumb instructions, if here any types of error that to be occurs, in this case the CPSR registers cannot be directly interact with the given instruction and also the error prone code. So that here all over the error to be recovered on debugging format through the help of indirect mode ways. So in this case the triggering bit to be active, that's your 1. After that, when the triggering bit to be provides the status bit, that's your 1. Then after instantly the thumb instructions to be created one default register for storing all over the error prone code data on few time periods. So in this case the CPSR code that to be retrieved and after that it to be performing on error free natures. Okay, that's your T equal to 1. Okay, so another one difference in case of ARM instruction and thumb instruction code, here whenever we have to executing the data value, every data value to be required some opcodes through which the data to be operate. Similarly, in case of ARM instructions that to be provides 58 core instruction, 58 core instruction opcodes through which all over the data to be operate. But in case of thumb instructions, we have to execute same instructions by using 30 core instruction opcodes. Okay, so that we have to use the thumb instruction for easiest method calculations in very certain time intervals. Now goes to our next difference in between your ARM instructions and thumb instruction. Here the next difference, whenever we have to calculating any types of arithmetical data manipulation, in case of ARM instruction, here the A boss to be directly mapping with the given B boss through the help of barrel shifter for performing their data calculations. That means it to be directly interacting with the A boss with the B boss, the barrel shifters. But whenever we have to performing these calculations through the help of thumb instruction format, here the data processing to be performed by using in separated ways through barrel shifters, and after that it to be combining with the data elements with the ALU bus. That means in case of thumb instruction, all over the barrel shifter code bit like your right shift arithmetical operator, right shift left shift operator, or rotate left or rotate right, which type of rotating data we have to performing shift by shift manner. In case of thumb instructions that to be executed in different ways. Okay. Now goes to our next difference. In case of ARM instruction, as we know, whenever we have to execute any instructions, here as it to be performing all over the data calculation on commercial purpose, so there is some constraints to be applied in every instruction executions. That means in case of ARM instruction, always every types of data and its of course to be executed through the help of one constraint, one conditions. That means some authorization code compulsory to be needed for executing any types of data value. So that here the CPSR register to be provides the 4 conditions for executing whenever the job to be manipulated on intermediate stage, like your C, then after that V, then another one flag, that's your N, and another flag, that's your J. That means 0, negative, overflow and carry flag to be used for the given status information about the job manipulations. But in case of thumb instructions, when we have to execute it through the help of registers, in this case sometimes the given constraints code cannot be executed. That means unconditionally some of course that to be automatically executed in case of thumb instruction. Every time we cannot be required for executing the constraints. Only that we uses some constraint or conditions in case of branch statements. In case of branch statement executions. Okay, that means here we have to use always the constraint for every opcode executions, but here we have to use the constraint only when the branch code job to be executed. Okay, so now goes to our next difference. In case of ARM instruction, when we have to performing any types of data calculations, as here all over the data to be performing in 32-bit format, so in this case all over the data elements to be very simple understanding. But as here in case of thumb instruction, every code to be executed by using compression format, that means the greater density format, so that maybe all over the job understanding nature is very complexity in nature. That means it is very complex nature, it is very simple nature for user understanding. Okay. The next difference in case of ARM instruction, here as the ARM instruction should be the parent of the thumb instruction, so the thumb instruction uses 65% ARM code executions. That means out of 100%, the given thumb instructions to be uses 65% of ARM instruction code executions. That means whatever the opcodes we have to use in case of ARM instructions, this given opcode also to be used in case of thumb instructions. Only that we provides one difference. Whenever we have to manipulate it all over the given opcodes, here the data size we have to take on independent way, but here all over the data size we have to take on dependability wise. That means here all over the data value always to be executed by using 2 address field, but here always all over the data to be executed there should 3 address field. So that we have to execute all over the data value in case of 100%, but in this case that to be 65% are code. And another one difference that to be provides in case of ARM instruction and thumb instructions, if we have to need for executing all over the data elements in case of multiplications, if we have to need for only acquiring the leftmost part of the data elements and denied all over the data elements which is to be present on the rightmost side, in this case we have used the thumb instruction. That means suppose our memory size to be suppose the processor memory size to be provides 750 MB locations, but when we have to interpreting any types of data value, in this case the interpreting data value to be required 1250 MB locations. So in this case the data cannot be inserted on this given location. So that the processor to be converting all over the data elements from ARM instruction to thumb instructions. That means on compression format, maybe some portion of the leftmost sides that to be eliminated, maybe some portion of the rightmost side that to be eliminated. That means that to be depends upon the processor code elements that to be executing by using your most significant bit or by using your least significant bit. Okay. After that, in case of ARM instructions, as here that to be executed by using 3 address instruction format in independent ways, so that here the memory architectures cannot be satisfied by using your von Neumann concept. But here the thumb instructions to be satisfied von Neumann concept. That means the von Neumann concept to be provides. We have to executing all over the different types of data value by using same memory location, where we have to store the operand, in same location we have to store the given resultant outcomes. Okay, that means there is That means here it will be required very less memory as comparison to ARM instruction for data manipulations. Okay. So on today's class we have to learn difference between your ARM instruction and thumb instructions. That means by using the given two instruction we have to processing different types of job in between your ARM processor. But only one general difference, in case of ARM processor we have to execute it all over the data value on 32-bit format when we have to use the ARM instruction. But in this case, if we have to need for compressing all over the ARM instruction 32-bit code on the half-word code format, that means 16-bit code format, in this case we have used the thumb instructions. Okay. So for greater density we have to use thumb instructions. Okay. So for today's class, that's all. If any doubt or conflict in your mind, then you can ask me with the help of comment box. That's all. Thanking you.